Welcome to the Deep Dive, everyone. Today we're presented by Safety One Source, and we're going to be talking about something really important, excavation safety.
Yeah, it's a topic that's, well, literally life or death.
Exactly, and we're focusing on a really fascinating part of it, too, the techniques of sloping and benching that OSHA lays out, keeping those trenches safe.
Right, and I bet you're thinking, I know trench safety is important, what's so deep about that?
Yeah, for sure.
Well, OSHA has this whole section, Appendix B of Subpart P, really detailed, and honestly, there's some surprising stuff in there, stuff that even experienced safety professionals can miss. Like, did you know that even something like traffic going by can affect how steep your trench wall can be?
Really? I wouldn't have thought about that.
Yeah, it's pretty interesting.
So this Appendix B, is this like the rule book for making sure excavations don't pave in?
Yeah, you can think of it that way. It's the engineering Bible for anyone who digs a hole in the ground, basically. And one of the first things it emphasizes is that you really have to understand soil.
Right, like soil testing and all that.
Yeah, and Appendix A actually goes into how to classify different soil types. It's important because the type of soil you're working with determines how steep your excavation can be.
Okay, that makes sense.
Yep.
Because obviously not all dirt is created equal.
Exactly, and OSHA knows that. That's why they have these maximum allowable slopes. It's all about the ratio of horizontal distance to vertical drop. The steeper the wall, the more dangerous it gets.
Right, especially if you've got the wrong kind of soil, I imagine.
Absolutely. It's kind of like, when you're trying to build a sandcastle on the beach, some sand just crumbles, right? But some sand holds its shape really well.
Yeah, good point.
And OSHA has, different categories for that.
So what are the different soil types? What makes a type A different from, say, a type C?
So if you're digging in stable rock, that's like your ideal situation. It's a type A soil. You can almost cut straight down, almost vertical. But if you move to type B, that's where things start to get a little looser. Think of it like slightly damp sand. It'll hold a decent shape, but you need a shallower angle.
Okay, type A is our rock star. Type B is still pretty good.
Right.
And then type C, that's our problem child.
Type C is like that loose, dry sand that just won't hold together. That's when you need a really gradual slope. And Appendix B has all the specifics. Like for type C, you need a ratio of 1.5 units horizontal for every 1 unit you go down. Really gentle slope.
It sounds almost like building a ramp instead of a wall at that point.
Pretty much.
So we've got these soil types. We've got these maximum slopes.
Yeah.
Is that pretty much the whole story with excavation safety?
Well, not quite. There's also this thing called short-term exposure. Basically, it means that sometimes you might be able to get away with a steeper slope if it's only for a really short period, like 24 hours or less.
Oh, so it's like a little loophole?
Kind of, but you really don't want to rely on it unless you absolutely have to. There are very specific conditions that need to be met.
Right. Better to be safe than sorry.
Exactly. It's always better to stick with those standard maximum allowable slopes whenever possible. But keep in mind, even those can change based on what's happening around your excavation.
Wait, really? What else could affect a perfectly good slope?
Well, think about it. You've got your soil, you've got your angle. But what if you have a big truck driving by or a pile of material stored right next to the edge? All that extra weight and vibration, it puts stress on the walls.
Oh, I see what you mean. So even if I calculate everything perfectly, something like traffic could throw everything off.
That's where Appendix B gets really interesting. It talks about these things called surcharge loads, all those external factors that can make a safe slope suddenly unsafe. And it puts the responsibility on the competent person at the site to be aware of these loads and make adjustments.
So it's not just about knowing the rules, it's also about knowing when to bend them. Safely, of course.
Exactly. The competent person has to look at the site, consider all the factors, and make a judgment call. Maybe the slope needs to be shallower. Maybe you need to use a completely different technique, like benching, for example.
Right, benching. So is that like the backup plan when sloping just won't cut it?
Benching is more than just a backup. It's a whole other way to stabilize an excavation. And Appendix B has a lot to say about it, but I think that's a story for part 2 of our deep dive.
So benching. It sounds kind of like building stairs into the side of a trench.
Yeah, that's a great way to think about it. Instead of having one smooth slope, you create these stepped levels with platforms and vertical walls in between.
And that helps to make the excavation more stable, right? Especially if you can't get a shallow enough slope with the soil you're working with.
Exactly. Benching is really helpful when you're digging deep, or if you have limited space to work with, or if you're dealing with those unstable soils we talked about. And Appendix B, it lays out all the rules for doing it safely.
So what kind of rules are we talking about? Does it get as detailed as those soil type tables?
Oh, yeah, definitely. Appendix B covers everything. It specifies how high those vertical walls can be between the benches, how wide the platforms have to be, even the allowable slope for the benched sections themselves.
So if I'm picturing this right, it's like taking that maximum allowable slope for my soil type and kind of breaking up into smaller, more manageable sections.
Yeah, you got it. And each of those sections gets that stepped, benched configuration, which just helps distribute the weight and pressure more effectively, makes the whole thing more stable.
That's pretty cool. So what happens when we throw those layered soils into the mix? Does benching help with those tricky scenarios where you've got, different soil types stacked on top of each other?
Yeah, benching can be a good solution for those layered soils. Remember how we said that the weakest soil layer usually determines what your overall slope has to be?
Right.
Well, with benching, you can sometimes get a little bit more creative.
Oh, really? How so?
So let's say you've got a layer of type B soil on top of a layer of type A. Normally, you'd be stuck with that 1-to-1 slope that's required for the type B, right?
Right.
But with benching, you might be able to create a steeper slope for that upper type A layer because it's supported by the bench underneath it.
So it's like building a little reinforced retaining wall for that weaker soil to sit on.
Exactly. And then you can be a little more aggressive with the slope above it.
That makes a lot of sense. So it's not just about those step-like platforms. Benching is a whole system for managing different soil types and pressures within an excavation.
You got it. But even with benching, there are limits. When excavations get really deep, like over 20 feet, it's a whole different ballgame.
Okay, so 20 feet, that's where those standard tables and rules kind of go out the window.
Yeah, pretty much. Once you go over 20 feet, things get a lot more serious. The risks are much higher. And that's when OSHA steps in and says, all right, you need to bring in a professional engineer.
Oh, wow. So it's not just about following the guidelines in Appendix B anymore. Now we need custom designed solutions.
Exactly. At that point, you need an engineer to come in and look at the site. They'll assess the soil, the depth, the surcharge loads, everything we've been talking about, and then they'll design a system to keep those walls stable. Might involve things like shoring or bracing, things that are beyond the scope of Appendix B.
So a whole other level of expertise is needed.
Yeah, for sure. The deeper you go, the more complicated it gets.
Makes sense.
Yeah.
But even with a professional engineer involved, the competent person on site is still really important, right?
Oh, absolutely. That competent person is going to be working closely with the engineer, monitoring the excavation, making sure everyone's following the safety protocols. It's a team effort.
It's like that constant vigilance we talked about before. Even with the best designs, things can still go wrong if you're not paying attention.
Couldn't agree more. That competent person is like the eyes and ears on the ground, making sure everything is stable and the protective systems are doing their job. They have a big responsibility.
This has been such a fascinating look into OSHA's excavation safety standards. We've covered so much ground, literally, from soil types and sloping to benching, and these really complex situations that require an engineer.
And remember, this is just a starting point. Appendix B is packed with information, and I encourage everyone to read it carefully and understand all the details.
We've laid the groundwork here, so to speak, but there's one more piece of the puzzle we need to talk about, those warning signs that tell you an excavation might be on the verge of collapse. What should people be looking out for when they're on site?
Yeah, those warning signs are so important. We can talk all day about regulations and best practices, but if you're not paying attention to what the soil is telling you, things can go wrong in a hurry.
No kidding. You really got to be able to read the signs, so to speak.
So what are some of those telltale signs that an excavation is in trouble? What should our listeners be looking out for? Well, think of it this way. The soil, it's trying to talk to you. You might start to see little cracks or fissures showing up on the face of the excavation, almost like wrinkles on someone's forehead.
Okay, wrinkles are bad. What else?
You might also see the edges of the excavation start to slump or sag a little bit, kind of like a cake that hasn't been cooked all the way through in the middle.
Oh, I see what you mean. So it's like the excavation is slowly trying to cave in, giving us a little warning before it goes all the way?
Right. And here's a really important one. If you see any bulging or heaving at the bottom of the excavation, that's a big red flag.
Bulging at the bottom. It's like time to run, right?
Pretty much, yeah. It means there's a lot of pressure building up down there, and it's looking for a way out.
So what should we do if we see any of these warning signs?
First things first, stop all work immediately. Everybody out of the excavation, secure the area. And then you need to get your competent person in there to assess the situation.
Because even if the initial calculations were right, something has changed and you got to adapt.
Exactly. And you know what's interesting? Appendix B actually talks about this. It says that if you see signs of distress, you need to make the slope even shallower than the maximum allowable slope.
Oh, really? So you got to go beyond the standard safety margins.
Yep. It recommends going to at least a 1/2 horizontal to 1 vertical slope, even steeper than that short-term exposure allowance we talked about earlier. It's like, hitting the emergency brake.
So it really highlights how important it is to monitor the excavation constantly. It's not just a set it and forget it kind of thing.
You got it. Things can change, and you have to be ready to adjust.
Well, there you have it, folks. A deep dive into OSHA's excavation safety standards, brought to you by Safety One Source. We've covered so much ground today, literally. Soil types, sloping, benching, those complex situations where you need an engineer. Even those warning signs that can mean the difference between a safe job and a disaster.
And remember, this was just a taste of what's in Appendix B. There's a ton of information in there, and I really encourage everyone to dig into it and understand all those details.
We've definitely laid the groundwork here. But remember, knowledge is power when it comes to excavation safety. It can literally save lives.
Absolutely. Stay informed, stay vigilant, and stay safe out there.
And until next time, keep diving deep.